Hey everyone, welcome to today's talk. Our speaker is Joel Chan. Joel is an assistant professor in the University of Maryland's College of Information Studies and Human-Computer Interaction Lab. He's a senior fellow at the Center for Advanced Study of Communities and Information. Previously, he was a postdoctoral research fellow and project scientist in the Human-Computer Interaction Institute at Carnegie Mellon University. He received his PhD in cognitive psychology at the University of Pittsburgh. His research investigates systems that support creative knowledge work such as scientific discovery and innovative design. His long-term goal is to help create a future where innovation systems are characterized by openness and sustainability. His research has received funding from the National Science Foundation and the Institute for Museum and Library Sciences, and he's received Best Paper Awards from the ASME Conference for Design Theory and Methodology, the Journal of Design Studies, and the ACM SIGKDD Conference on Knowledge Discovery and Data Mining. I am assuming there's not a quick way to abbreviate those letters there. Joel, I'm very excited to have you talk with us today. You take it from here.
All right. Hey, thanks for the intro and for the invite. I think the backstory is that we got connected somehow through Adam Marblestone, maybe. There's this kind of shadow network of people interested in meta science and meta innovation and infrastructure. So I'm really excited to talk to you all, and there's a kind of a fun backstory from my end. I knew about Protocol Labs through the Underlay project, and I was really sad to miss the talk, I think a couple of weeks ago from Joel Gus. I don't know how to say his last name. But yeah, so that actually is a kind of a nice connection to a lot of the themes of this talk. So let's jump right in. Here's my goal. This is a current thrust of mine. I want to remove barriers to effective synthesis so that any scientist can ask better questions faster. That's the goal of this line of work. It's really occupying most of my attention right now. And what do I mean by synthesis? I kind of started with like the idea of lit review as the thing that scientists need to do better, but actually I kind of came across like, I think synthesis really captures it better. This idea of constructing a new conceptual whole that's innovative. And examples of that include a theory, a model, a design space, and an effective literature review or systematic review, right? So the idea is it gives you sort of a map of the territory that allows you to explore efficiently in new ways. I like to show this example as a illustration of how synthesis drives scientific progress. So this is a picture of Esther Duflo, Nobel Prize winner a couple of years ago in economics for developmental economics. And something that struck me was she wrote an article in 2011 in a newsletter for aspiring women scientists. Like how do you find the right questions? How do you do good work? And she mentioned one thing that was really interesting. She credited her Nobel Prize winning line of work to a handbook review chapter that she's just happened to come across during her second year of a PhD program that really laid out in a really impressive and systematic way the open problems in the field of developmental economics. And she was able to see, okay, so here are the real important problems. Here are the gaps. And it turns out that, it matches with the things that I know how to do. And so she worked her way through this map and came up with really important discoveries that turns out, were Nobel Prize winning. Really important. On the flip side, without effective synthesis, we risk wasting our time on questions that are trivial, impossible, misframed, and more. One of my favorite quotes is from Alan Newell. You can't play 20 questions with nature and win. You can't just keep running experiments and hope to kind of get to the answer. You need to synthesize. Unfortunately, synthesis is really hard. So there's kind of a scattering of literature on understanding the process of synthesis. It's kind of this black box that people just assume that you need to do as a researcher, but you don't really teach how to do explicitly. So we have some literature studying what it's like to do systematic reviews. And turns out it's extremely costly, extremely hard. So much so that most reviews are never updated. They become obsolete very quickly after their publication because nobody wants to update them. It's just too much work. And this is probably a lower bound on the cost of sense making for collective synthesis because systematic reviews are a special case of synthesis. They address a very singular question, right? What's the effect of this intervention on this outcome compared to this comparator using randomized control trials only, right? Single kind of evidence, single question, whereas interdisciplinary syntheses are typically far more complex. We have some ethnographies and observational studies that kind of capture the experience of doing synthesis well. And this phrase enslaved to you feel enslaved to the trapped data, right? You're fighting against the system to really get your work done. So this is also getting harder. I like this line of work by Ben Jones talking about the growing burden of knowledge that's motivated some really important work, such as the distill.pub, for kind of making it easier for us to climb the ladder of knowledge to get to the frontier faster. It's continuing to grow though. The papers are piling up over time. And we're increasingly seeing that we can't just scale a single mountain. We have to converge. A lot of our problems that we care about is not possible to decompose cleanly into attacking from a single angle. So we have to synthesize across disciplines. So I'm concerned about this. We're coping, I think, for now. Like nothing's broken yet, as far as I can tell. We're not seeing any kind of like, most published discoveries are false kind of moment yet. But I think the cost is invisible. So we're coping right now by spending a lot more time. It turns out scientists are increasingly older when they win a Nobel Prize and when they get their first PhD. They're taking a longer time to get to the frontier. And we're sort of coping by trying to put our heads together into teams, but that has its own overhead. It's hard to find the right people. Teamwork is hard, and funding is hard for effective synthesis teams and centers. So we're pouring a ton of resources into the research system right now. And there's kind of this line of work studying from economics point of view, like what's our ROI on our investments in research. And the picture is a little bit controversial, but there's some fairly consistent signs that we're putting a lot more in than we're getting out right now. We're getting declining returns on investment. So I'm concerned about this because we're sort of like pushing really hard. And I'm worried about negative externalities, right? So our current coping mechanism is just to try really hard, put lots and lots of money into the problem, try really hard, throw more people into the system, spin the wheel faster. And I think this has pretty serious negative side effects. We have lots and lots of intense competition. There's lots of people are in the space. And so we have consequences for reproducibility. People cut corners. People kind of get squeezed out because there's poverty of attention. And in general, I just think this is really bad for science. I just came across a paper last week talking to scientists about how they perceive current publication culture. This really stood out to me. This was a discussion point. It said most PhD candidates have rather naive opinions about contemporary publication culture. They argue that science should be a genuine quest for truth and see scientists as truth seekers who focus on scientific quality. And this is considered naive, right? I don't like that. That's not what we want, right? So we see this kind of jadedness coming on as you progress in your career. I don't think we need to accept the system as it is. So that's what I'm interested in. How do we make it make synthesis easier? I'm going to conjecture, this is the basis of my talk, that synthesis is hard because most people lack effective infrastructure. So I'm going to assume that people want to do synthesis. People want to do science well. They start off, we saw that, right? You start off your career as a PhD student, you do want to do effective science, you do want to synthesize, you want to build on body of knowledge, but you eventually kind of get eroded. And I think it's partially because you don't have infrastructure. So infrastructure means a lot of things to different people. I'm coming at it from the perspective of social science of infrastructure. So studying it a little bit more broadly than just kind of pipes and wires. And the core idea is that infrastructure is what it is that helps us get things done reliably and sustainably. right? So we have infrastructure for code libraries, we have infrastructure for getting to and from cities, we have transportation networks, and we kind of forget that they exist because they help us just do the thing we care about. We don't have to worry about fighting the system to get our stuff done, except when the infrastructure fails, right? So infrastructure is usually invisible until it fails. And this is kind of a tenet of infrastructure studies where to understand what infrastructure exists, we look for the places where people are annoyed. And then we realize what is actually there. What's the infrastructure like? My argument is that if we think about what we actually need for synthesis and compare that to the infrastructure we have for communicating and sharing science, I think there's a pretty strong mismatch, right? So think about when you're doing a lit review or synthesis, what kinds of questions do you actually want to answer? You want to know what are the unsolved problems in domain X? You want to know what solutions have been proposed for those problems, what extensions have been proposed, what generalizations. You want to know what the main phenomena are, what are the findings, what are the major theoretical explanations, and how do they compete with each other? What are the major lines of evidence? Right? So that's what you actually want to know and want to kind of work with. Those are the materials. Think about that as the standards, right? Compare that with kind of mainstream infrastructure, right? So infrastructure is like the one that everybody has, right? Everybody has Google Scholar. Where are the theories, evidence, problem solutions? We got papers. We have citations that kind of helps us a little bit. We have time. That's pretty much it. There's no way to really zero in on these things that we really care about. It's not there. The infrastructure privileges papers and people and time. Semantic Scholar has been working really hard on this problem, and I'm happy to talk more about some really cool stuff that I've seen, experimental stuff that they're doing. But by and large, it's kind of the same thing, right? The fundamental unit is not the thing we care about, but papers, right? We still have lots of kind of papers here. And you can kind of filter by fields of study, date, whether it has PDF. Like look at these, like what are the ways that you can explore this space? Gives you a clue as to what it's optimized for. And the answer is not for synthesis. So people kind of get around this, right? So they, like I said, they spend lots of time. I didn't include a graph of the breakdown of the cost of doing a systematic review. A huge chunk of it is basically fighting against this infrastructure. You have to do a ton of screening because a lot of stuff is irrelevant. And you have to kind of go around the search systems to make sure you don't miss anything. And then you have to get the papers and extract the thing you actually care about. And that goes into the ether, and the next team starts from scratch again. The alternative is network-based solutions, and this works really well. So this is the state of the art right now, right? So if you are lucky enough to work at a world-class institute with people from many different disciplines, experts, then you've got it made, right? That's the best infrastructure. You go talk to them, and you get this nice interactive discussion, and you get to the things that you actually care about. Like they'll tell you about the open problems, they'll tell you about the different lines of evidence and arguments and so on. I think it's fine. I'm not gonna replace this, but the thing I don't like about it is that it's not open and sustainable in the sense that I care about, right? So, what if you don't work down the hall from the world's expert on X? What if you don't have money to fly to a conference to meet the experts? What if you don't have money to spin up, sustain a world-class synthesis center? This is a persistent problem with synthesis centers. And what if you don't even know who might know what you don't know, right? There's all kinds of problems with network-based solutions. So what I'm interested in is how we can build infrastructures for synthesis that are open and sustainable. So that's the core question here. And we can frame this into kind of two subproblems, okay? So we can talk about, on the one hand, foraging, right? How do we find the conceptual spaces and ideas that we want to work with? And on the right side, we can talk about sense making. So this is a model of sense making that's a pretty good starting point for understanding the process of synthesis. This is a classic notional model of sense making from Peter Piroli and Stu Card, right? And see this loop. This is a model of sense making and intelligence analysis, right? You find the evidence that you care about, and you're trying to loop over it to build a schema and eventually make sense of it and understand what's going on. That's very similar to what we're doing with synthesis, right? We need to find the relevant things, then we need to synthesize them. So I'm going to try to target each of these branches, right? Think about how do we build infrastructure that will support each of these key operations better. So there's going to be kind of two broad classes of work. One is this idea of analogy-powered portals into new conceptual spaces. This draws on my background in cognitive science studying analogy. And on the right is kind of a newer line of work that I think actually aligns. That's why I came to know about protocol labs. This idea of a different infrastructure. Instead of paper-centric scholarly communication infrastructure, we have maybe something like a discourse graph that's shareable of scientific literature. I'm going to spend a little bit more time on the first branch, and I want to make sure we have time for the second branch as well. So let's talk about the analogy powered portals. Okay, so this targets the kind of unknown problem, right? So how do you know what important perspectives on your problem that you're missing, right? So you want to know what are the different ways to approach this problem that I'm thinking about, right? One example is the history of simulated annealing, right? So you're kind of dealing with this problem of trying to minimize error in your model and avoid getting stuck in local minima. And it turns out that there's an analogous way to approach this problem from metallurgy, right? Of varying the cooling and heating schedule, right, to minimize imperfections in it. This was actually described, this analogy was described very explicitly in kind of the classic paper on simulated annealing. What does it take to get this portal into this novel conceptual space? We need something like a structured representation, right? So this analogy is similarity in terms of relations instead of entities and objects, right? So minimizing imperfections by heating, cooling gradually, instead of in spite of similar surface features, right? So we try to ignore things like color if they're not relevant, application domain, right? We have to sort of ignore the fact that one's in a computer model and one is in a kind of physical substance, right? And to kind of zero in on that key relational similarity to understand there might be something here that we could understand for our problem. There's a long history of work trying to tackle this problem. A lot of roots in my discipline of cognitive science on the left here, kind of overlaps with case-based reasoning, expert systems trying to represent knowledge in a very formal way. It turns out if you handcraft these kinds of predicate calculus representations, computer models can do a really good job of crossing disciplines and finding analogies. But these are really hard to obtain, right? So in the domain of design, some people have been trying this. It can take tens to hundreds of hours to represent a design or technological object in this manner. And so it just doesn't really scale. It's really hard. On the flip side, we sort of have the dominance of kind of machine learning approaches that are kind of iffy on structure, right? So we still don't quite understand what kind of structure they're able to develop. We have some new reports that GPT-3 is able to kind of auto-complete some analogical prompts, but I don't think we really understand what's going on yet. It's not really tuned for that yet. So even though it's fast, I'm not so sure that it's able to cross disciplines and really get the structure that we want. You may remember the famous man is to woman as king is to queen analogy from Word to Vec, and happy to talk shop about it turns out it's pretty complicated. These four-term analogies don't work super well for the kinds of things we actually care about. There's kind of interesting, because it's operating over so much data, it's exploiting irregularities in the data that kind of allow it to ignore the relational structure. So we're trying to find something that can scale reasonably well, right? It's more sustainable, but also has some degree of structure that allows us to find analogical connections to new conceptual spaces. So we've been playing with this idea of kind of this intuition of intermediate structure representations. So what if we were able to kind of dissolve research papers into semantic chunks that signal its relational structure, such as what's the purpose or problem that the paper is addressing, and what's the proposed mechanism. And then instead of matching based on the entire paper, we match based on those elements which are hypothesized to be especially rich in terms of relational structure. This is rooted in the idea of analogical schemas from cognitive science of analogical problem solving, right? You may have, I don't know if you heard of this, the classic radiation problem, right? So if you're a doctor on the right and there's a patient with a tumor, you have this powerful ray gun that's so powerful it can kill the tumor, but also kill the patient if it passes through the skin. And so the problem is, how do you kill the tumor without killing the patient? And we give you this story about a castle and a general attacking the castle. And the bridges are so flimsy that if you send all your whole army at one time, the bridge collapses. So the solution is to converge from multiple directions, and that gives you this schema of addressing this problem with a convergence schema, right? It's a classic problem in analogical problem solving. So in the case of research papers, you can kind of squint and see something similar here, right? So in the case of the similarity annealing, we have the problem of minimizing error in a model. And we have an analogous problem of minimizing imperfections in a substance in metallurgy. The solution here is by increasing and gradually decreasing the temperature of the substance. And the explicit analogy was, what if we transferred something similar over about this idea of increasing and gradually decreasing temperature of search? What does that mean? Turns out you can do these random restarts and sort of change the probability of restarting in a different location. And that turned out to be a very fruitful analogy, right? Give you a new perspective on the problem. So we've tested this. This is the KDD work, actually. So that's how we say the conference. In a simpler domain with product descriptions. So we can get some crowd annotations on product descriptions like this, right? So we say, hey, look at this product description and highlight the parts that you think are what the product is for. What is its purpose? And then highlight the parts that tell you how it works. What are the mechanisms? And then we train a bidirectional GRU RNN to predict two vectors, a purpose vector and mechanism vector, based on an input document. And it turns out we're able to do this fairly well. So we can pass new product descriptions through this RNN, and we can get purpose vectors whose closest words to that vector are things like making energy in yogurt, and mechanism vectors whose closest words are something like vacuum, cooled, and drum. And what this allows us to do is to escape kind of surface similarity. So here are kind of three examples of sets of similar results that you might get based on random matching over a corpus of product descriptions, glove TF-IDF vectors over the entire product description, or glove TF-IDF vectors only for the purpose and mechanism vectors, right? So you can see in the case of the normal infrastructure of kind of overall similarity, we get very cell phone-y type things, right? For the problem of charging a cell phone. But if you abstract away the cell phone and focus only on the purpose of charging, we're able to get things like a USB tower with backup battery, human pulley-powered generator suit, which was a real idea in the corpus. And these are both new and relevant, as opposed to if we just randomly sample, we get things like shampoo pods and dog meetup apps that really don't help us. And if we give these different sets of results to participants and ask them to generate ideas for problems, we see a pretty strong effect of getting more creative ideas if you get these inspirations from a different domain compared to getting kind of your standard cell phone-y type things or random things. So we have some reason to believe that this will work. We have, similar intuition. As I said, researchers also work on problems, right? You can see this is a abstract from one of my papers, right? The purpose here is to address the problem that synthesis is hard, essentially. In any online community, if you want people to synthesize things, you have to get them to do annoying tasks that they want to do. And a solution for this problem, this mechanism, is to design a integrated crowdsourcing system where we naturally integrate tasks into the thing they actually want to do. Right, so we can see probably you do this already when you read papers, right? You try to identify what were they trying to do? What's the main purpose of this paper? And what did they contribute? Right, so that intuition is I think, sound. We do have some challenges. Language can be very complex and jargony. We don't know if crowds can still produce useful annotations in a timely manner. Sometimes you have multiple problems at different levels. You may want to zero in on one thing. So we tested this. It turns out crowd workers, even with no specialized background, can still do this surprisingly well. They do this relatively quickly, about a minute or so per abstract, and surprisingly accurately. So even if you are just kind of a not specialized worker on online labor market like Mechanical Turk, you still achieve up to 60% agreement with researcher annotations. And if you're a specialized Upwork worker, like a copywriter or something like that, you get 80% agreement. So we have some indication that this can scale. Yeah, you can kind of eyeball it and see, the Upwork and researchers have fairly good overlap in terms of the reds are purposes and the blues are mechanisms. MTurk is a little bit different, but not too far off. So what does this allow us to do? So we kind of tested this by saying, okay, let's take a corpus of papers where we know there are analogical relationships within that corpus. So we looked at this kind of interdisciplinary conference computer supported cooperative work. And we looked at, let's try to match papers based on overall similarity versus purpose mechanism vectors from expert annotations, Upwork, and MTurk. And these blue lines here are the purpose mechanism vectors, and the black line here is the overall similarity. And what you're seeing on the x-axis here is, let's take the top 1% similar pairs based on each of these metrics, and then see what proportion of the top 1% is an analogy that we already knew about, what proportion of the top 5%, what proportion of the top 10%. And so you see a fairly consistent advantage. We're able to refine analogies that we already knew about. Just to give you an intuition, it's not just that we find more, but we find kind of different analogous research papers, right? So this is an example of something you would get with overall similarity. These are kind of near analogies. On the top here, there's a schema of improving creative idea generation by cost-effectively identifying diverse idea sets. And then we match it to a paper that's about improving creative idea generation, right? Same kind of domain, by identifying diverse idea sets with crowdsourcing. So these are analogous in the sense that they are the same problem, and also the same mechanism and the same domain. In contrast, we can kind of get away from the creative idea generation context a little bit with a purpose mechanism schema and find something like, hey, how do we cost effectively identify good workers by using crowdsourced peer review? So we've gotten away from the idea generation context, maybe get some new perspectives. And we can kind of get a feel for what's going on by looking at the vectors, right? The top words that are closest to the purpose and mechanism vectors. And you can see that we're seeing some similarity across Q rating and organizing with repetition scores and ratings. And this is fairly different, right? Grassroots and peer sourcing. We also did a second evaluation where we talked to an interdisciplinary mechanical engineering lab who was interested in creating new 2D and 3D structures at many different scales by applying tension to stretch full polymers. And they are struggling to discover other papers for competitive analysis, right? Who else is working on this problem? Inspiration, what other mechanisms might we use? applications, right? What other problems could be solved with our polymer tension techniques? So we talked to lead PhD student in the lab and used their research proposal as a query. And then we found a bunch of matches from both a purpose mechanism approach and kind of overall similarity. And out of the matches that we got, about 50 from each, we got, more were judged as relevant and new from purpose mechanism and 2 from overall similarity. So I wouldn't put too much weight on the numbers here. What was interesting, I think, was qualitatively, the matches that we got from our approach were fairly different, right? So when you do overall similarity of the abstracts, we get something very super directly relevant, like manipulating the structure of a membrane in a controlled way by applying tension to the membrane, very similar to what they're actually doing. So fine for competitive analysis, but in terms of inspiration, we're able to get things like generate a variety of geometric structures using multi-agent systems, which kind of led her to wonder about kind of agent-based modeling as an alternative approach to controlling what's going on at that nanoscale level. So we get some evidence that this is working. So it's pretty exciting, promising results. And I think it's working mostly by achieving some degree of abstraction by ignoring irrelevant surface details, right? So whatever is not the purpose and mechanism, we can kind of abstract away the background, the context. But the analogical distance is still limited without direct abstraction. So that's still a work in progress. We still have basically vectors based on these exact words, right? So we can't actually get away all the way away from specific words like crowd, for example. But we can abstract away from the context a little bit. So that's very helpful. Something that we're doing now that is interesting to think about is we've been deploying these. We have a working prototype right now, and we've been testing it with people. And one thing we notice consistently is that it's fairly hard to get value from a new conceptual space when you're only given a paper from a different field, right? You look at this paper and you're like, I don't understand these terms. I can't recognize the value. And more perniciously, often the idea in the paper is just not really useful. It really isn't. What's useful is what it opens up, right? Through conversation, through exploration. Then you're like, oh, I question this assumption. I find this other thing that's relevant. And so you kind of don't get that if you're just sitting in front of a search engine, right? So we're thinking, how do we think beyond this kind of search engine paradigm? Can we, for example, integrate this into cross-disciplinary matchmaking at conferences, for example, right? Can we help connect you to guides? So we're exploring this concept right now within our college, which is very interdisciplinary, right? So how do we use analogy to augment cross-disciplinary matchmaking? So suppose you start with a problem. We have an analogical matchmaker module, which we now make socio-technical by integrating a person who might be motivated to do this, like a dean of research, a community leader, someone in a structural hole. And we augment them with analogical search, and then we give them the ability to find entry points. These papers are now entry points instead of the final be all end all. We also use the analogical matchmaker to help construct analogical prompts that you can then go talk to guides who will be kind of similar to the entry points. Kind of glossing over a lot of details here, but it's a general concept of instead of just giving you an entry point, we give you something to talk about it with someone. And hopefully that helps you explore the novel conceptual space. So just a kind of worked example, right? So this is a actual pilot participant. She's interested in how to equip tech workers to design technology in an ethical and just way. We prototyped this with the analytical search system and kind of reformulated the query to talk about one thing that's hard about ethical design is that it's hard to reason about the complex consequences of your design choices. And so we plugged that into the system, and we got a paper on real-time synchronized Petri nets, which means nothing to the original person, but kind of sparked this idea of, well, in what ways is the problem of reasoning about the behavior of complex distributed systems similar or different to the problem of reasoning about complex socio-technical ethical consequences of design choices? It may turn out that Petri nets is just not useful at all, but this idea of finding compact representations of very complex systems might be useful, right? And so we give this prompt to the person and have them talk to somebody in the college who knows something about complex distributed systems. It turns out somebody in the department worked on world clock synchronization when they were a PhD. I think that was their PhD, yeah. So that's the concept, and we're kind of prototyping this right now. We expect this to be much more fruitful. We were not going to waste these kind of valuable entry points and actually have people develop value from them. Okay, so that's the end of the first part. And we got a little bit of time left. Let me see, what's the time here? Good. I'm going to move quickly to this last part and then make sure we have time for discussion. So this is part about shareable discourse graphs. And this is addressing the problem of, okay, say I find you a bunch of relevant papers, now what? Your sense-making ability hasn't changed. You still have to extract all the stuff. And this is probably a familiar experience for many of you, your endless reading list, right? Just read this. For the love of God, just read this. And then you have this empty folder of read stuff, right? It's really, really hard. You're fighting against the system, right? The problem is that you want theories, claims, evidence, arguments, not papers, right? That's what you actually want. That's the infrastructure that you want. So we're kind of wanting to think beyond Spotify and iTunes for papers is my kind of analogy. And think about this idea of discourse graphs. So this is a paper in Science from 2009 on what scientific reading will be like in 2019. It turns out it's not yet, but this is still the vision, right? Imagine if you could navigate repositories of assertions that are connected in relationships of causal ontological natures, connected to shared annotation databases, right? This is the thing we actually care about, as opposed to the kind of the paper containers. This is a very widespread vision, right? So I'm not very far from the first to think about this, right? Give you an intuition what it might look like. We've got these claims, right? They're connected in rhetorical relationships, and they're connected to the context. Who wrote this? Where was this observation made? With what setting? What was the measure? What was the actual result? And having all of these integrated into this discourse graph. This is ultimately what you want. This is what systematic review people spend a ton of time, basically half of the budget to get to this point, right? What if they start with this right away is the question. Tons of people have been working on this forever. The warehouses are built. Basically, we've got really formal and mature standards for how to represent these discourse graphs. We've got nano publications, we've got micro publications, we've got research objects for integrating claims with data, for example. The problem we're having is that it's hard to fill these warehouses. So there's an evocative phrase from the author of Nano Publications talking about, we want an ocean of nano publications, where right now it's no more than a puddle. It's really hard to get people to contribute this. We have kind of, on RO Hub, which is for research objects, we've got 90 active users. On nano publication servers, we have a ton of nano publications, but they're all from 41 authors and mostly within bioinformatics, right? So we have a pretty serious authoring bottleneck. So far, we've explored kind of specialized curator models, right? We have these crowdsourcing citizen science, or have scientists basically, instead of publishing papers, get them to do a separate task of publishing semantic publications, or people are exploring text mining. I'm kind of bearish on text mining alone. These are very complex sense-making tasks, and I'm not optimistic about our ability to solve that until we basically solve NLP. So I think it's NLP hard. So what we're working on is, let's think about this infrastructurally and think about the fact that people are already doing this work. When you read a paper, you are transforming it from that annoying container into the things we actually care about, the claims, the context, the evidence, but it just disappears. What if it didn't disappear? And what if we were able to share these intermediate products of synthesis in a peer-to-peer discourse graph commons, for example, right? And we don't have to motivate you to do this work because you already do it. We just have to build the infrastructure to enable you to share that with yourself and others over time. Right, so the basic idea is, give you the tools to build your own personal discourse graph for yourself, It makes your synthesis better. We don't have to motivate you. We give you the tools to share and federate with others to improve collaboration and networking, right? No need to force you, makes you smarter. And then next time you or someone else starts a new project, you draw on the discourse graph instead of only papers. And we believe that will help you get to the frontier way faster. So we're currently piloting this process, a conceptual and process model for how to build your own discourse graph in your notes. It requires specialized software, which I don't know if some of you might be familiar with. So the intuition is to move from something like this that's very paper-centric and kind of disconnected, right? So very typical to have something like a executive summary, paper summaries, and paper databases. This is a really valuable, actually, evidence summary ongoing on COVID and children. To transform that to something like this. So this is a screenshot from a pilot we're running in Rome Research. It's a hypertext note-making environment where you essentially have the same information but represented in a discourse graph-like manner. And I'm checking the time here. I do have time to click through to show you, right? We have questions, we have claims, and we have findings and evidence, right? So if we're concerned about transmission of COVID in children, right, how susceptible are they to infection? We have competing claims, right? They're half as likely to contract COVID given equivalent exposure, or they're equally susceptible. What's the evidence? Let's look at this one, right? This study found that there was no confirmed transmission to 1,000 children who were symptomatic close contacts, and this is where they were, in Ireland, right? And this is a lot more explorable, and imagine if you started with these collections instead of all of these papers and you had to extract them, right? So this is the intuition behind these shareable discourse graphs. Okay, so let's see, where's my presentation? Right, okay. So it's not as foreign as it looks, right? So like I said, many people do this already, particularly the young and naive early career researchers, right? They spend this time to actually process papers and they think about what are the arguments, what are the evidence. This is a template from one of our participants. This is a summary from one of our participants. People do this work already. It's not that foreign. They are extracting these things already. We just need to figure out ways to ease them into a slightly different environment that is amenable to sharing. That's the goal. Okay, so yeah, so we're piloting this now with a pilot project on COVID in children, as independent researcher on misinformation, trying this out, the system out, a biomedical research lab, and my own lab. So if you're interested in seeing what this looks like in terms of my thinking, you can go to this URL. This is my shareable discourse graph. If you're interested in anything about synthesis or innovation. So I'm going to close out here. So we're approaching this from an infrastructural standpoint, right? And one of the key points from social science of infrastructure is that people are parts of infrastructure. Knowledge flows through people, not just builders and pipes and wires. And so the implication in meta pattern is to kind of approach this problem of open and sustainable infrastructures by building tools that integrate into existing social and institutional infrastructures, taking seriously what people are already doing, where they are, and try to integrate into that instead of getting them to do something entirely different. And to think about AI as augmentation instead of automation. Okay, so that's it for my talk. I'm looking forward to the discussion.
Yeah, thank you so much. That was a really interesting talk, and a lot of really neat ideas. I'm interested in this distinction between finding fields or papers or ideas that are similar versus ones that sort of provoke useful research directions.
Yeah.
And like, to what extent is there a difference between those two? And which one are you sort of most interested in, or are you just interested in both?
I'm interested in both, and I think we do a better job with the first one right now, right? So our infrastructure is trying to aim for precision right now. So we have all these control vocabulary and trying to make sure that you find exactly the thing you're looking for, right? Exactly what are the findings or what are the papers that directly deal with vitamin B6 and directly deal with this particular molecule, right? It's all this great work trying to really enhance the precision. But there's really interesting things that happen with mismatches. And right now, it's easy to kind of get lost in between 0 and 100, right? Either 0 is like super, super precise, and then 100 is like totally irrelevant and not helpful at all. But finding a way to find, just a little bit of a mismatch, like, this like minimize error, minimize imperfections, they're not really the same thing, right? They're not, they really aren't. But it provokes an interesting different way of thinking. I got my 18-month-old here with me. Yeah, so that's the second one is where I'm focused in on the margin, just because I think we do a lot more better job with the first one than the second one.
Yeah. I guess, yeah, are bridges similar to lasers in radiology, and like what sort of system would give you that?
I don't think they are, right? There's very significant mismatches, right? The problem with the bridge is that it collapses, and the problem with lasers is that it destroys the tissue, right? So it's not a perfect analogy at all. And I don't know, like it's those kinds of like interesting mismatches that maybe make you question assumptions and see things in different lights and so on. Yeah. So that's really hard. And I don't think you can do that by just staring at a paper, right? You got to be in conversation with someone and kind of work through the problem. And so that's what we're exploring now.
I'd love to continue in that direction a little bit, because it feels like there does seem to be this spectrum of specificity to abstraction.
Yeah.
And if you're like, I don't even have a good sense of how to quantify how specific something would be in order to tune that to try to explore. Do you have a sense of like what quantification of specificity would look like?
So that is a very very seductive question that I've been seduced by a lot, which is like, how do we find like the right level of abstraction? And I've basically given up on that because I don't think that it's possible to predict in advance. It kind of emerges through, like, it's not possible to a priori, I don't think, really tell like this level of abstraction. And so I'm moving towards like, how do we build systems that are robust to enable you to explore up and down, right? To explore different formulations, right? So that's where the discourse graphs come in about like preserving. Abstraction is great, but it's actually harmful if it's disconnected from its context, right? It can be powerful, but then you're liable to come up with like, bad inferences and so on that you can't recover from if you don't have the context, right? You forget that the map is not the territory and things like that. And so like preserving this structure that allows you to move up and down, and part of that is talking to people because they have the context. I thought very long and hard about this question of like, can we find exactly the right way to represent this problem in a way that maximizes connections to different disciplines, but minimizes error. And maybe someone smarter than me will figure it out, but I've basically given up.
I mean,
it's kind of interactive
to
right
me,
now.
Like, speaking of interactivity specifically, it seems like you could probably quantify abstraction through some interactive protocol in a way that you cannot.
Right. Yeah. So it could be like a
priori. Here is like general like descriptions for this idea from abstract to general.
Yeah, I think that's right. Yeah. Kind of having that signal emerge through use instead of trying to predict it based on features of the object itself, for example. Are you getting? I think I'm worried that I'm frozen, or is Evan frozen?
Evan's frozen for me.
Okay,
yeah.
Okay, so it's not me. Okay,
Yeah,
there's
yeah.
no connected. Yeah, so that's very productive. I'm really interested. I like that idea because it's ongoing. It's like this kind of idea of like a system that's adaptive over time. So how do we feed those signals back in the system is really interesting to me, and it kind of connects to this question that someone brought in the chat about tracking relevance, tracking reputation, right? using usage as a signal to feed back into the system to then say, okay, these directions are promising, these aren't, is very compelling to me.
Yeah, that's me in the chat. Hi, I'm ZX.
Yeah.
Thank you for the talk. It's really exciting. And then I have been thinking about something along this direction a lot. And I think like the technology that we developed here at PL, like lends itself really nicely to what we're talking about here. Because
I agree.
now we have this like graph, and then you can create like add nodes to this graph, and then there's some kind of attribution that can happen. From that graph. I'm just wondering what would really, and also this idea of a commons or like a DAO is very fitting to like all this industry that we are in. And then basically the community can decide what would be a good algorithm to, let's say, do the attribution, like let's say like every month, every week, and so on and so forth. And I feel like I'm wondering what can really unblock us and make it more progress, maybe like a POC or maybe like some kind of like perhaps it's like some kind of standard, and then some kind of game that we throw on top to get people really interested and engaged. That's something that would be a really good.
So I got two responses. So one is someone else already brought up a good context where that's happening, which is polyplexes, right? So that's one of the state of the art right now. They are using, I believe, it's the micro publication model. They actually call it micropubs. But it's not quite micropubs because they don't really have evidence integrated in context. But they've got a really special context there where everybody wants to win grants, right? So I don't know that their game mechanics incentivize building on other people yet. Maybe it does. The modal number of micropubs that people build on tends to be about 2, I think. But that could be an environment. My general answer is, I think the blocker is having communities of use where this is actually happening so we can play out with these ideas. Because I think there's a ton of really good standards and technical concepts that we can apply. We just need to figure out how it will work in a real context. So polyplexes is one. And then another one I can point you to is I showed you the tool for Rome research. They are running these what they call Rome games right now, where they're trying to figure out how to people are competing for prizes, but they're also trying to compete for ways to figure out how to attribute value to each other, how to assign credit. And so that's a place where there's a serious context of use. People are actually trying to do this, and the technical infrastructure is amenable to this kind of thing because they're doing very granular citation of each other's ideas through block references in the hypertext interface. So finding these places, I think, is the bottleneck of getting out of the lab and into like a place where this is actually happening, so we can try to debug which parts of the infrastructure do we need to kind of tweak to make it happen. And that's what I'm working on. And I think that's the real blocker is finding the places where this is actually happening. It's kind of a chicken and egg, right? Because we have these. One of the reasons it's hard is because we don't have good tools, but if we don't have good tools, then we don't have good context of use because people aren't doing it, and then we can't figure out how to build tools better. So how do we solve this chicken and egg problem?
Yeah, like another one I'm thinking of before is like let's start simple, like a meme network. Let's like use that to like educate the concept and then make it adopted, and then we can move up the level of complexity.
Yeah.
But I'm happy to discuss more after this. I think this is very fascinating, and there's something really big here.
Yeah. Thanks.
Yeah, thanks a lot, Joel. This talk has been fantastic and really thought-provoking. Following on ZX's question, I was thinking about the polyplexus model. I bring that up. My colleagues are probably sick of hearing it constantly, but it makes me wonder how many of these different graphs do you think can be supported? Like, is it necessary to have just one graph to rule them all, or can there be multiple context-dependent graphs or smaller graphs?
The latter.
How is the scale of the graph like?
The latter. I'm very skeptical of having a single graph that, as Joel very eloquently put, as the knowledge graph grows and kind of encompasses more, it's very, very difficult to have it be useful. There's no view from nowhere. So my vision is like, again, integrating with institutions, right? So you have like, SIGCHI, all these communities of interest in societies that would be interesting contexts for maintaining these context-specific graphs. And then the question is about how do you federate those? And that's kind of out of my technical expertise, but I know that people are working on it, including y'all, right? How do you kind of merge different schemas? How do you enable communication across different protocols? I think that's what we want to do instead of figuring out how to merge them into a single one. Like, accept that the useful ones are going to be context specific, and then figure out how to enable people to hop between them and kind of navigate the federation. The future is polycentric, exactly. It's tricky though, right? Centralization has a lot of advantages. Decentralization has a lot of costs, and it's tricky to. But I think smarter people than I are figuring out. There's a really cool project from Ink and Switch. I think it was called Project Cambria, like figuring out how to migrate different schemas that I found very, very useful. And then we have, of course, the federated wiki stuff, and a lot of ideas that I think we can borrow from the world of Git, for example, version control. So there's no shortage of technical ideas that I think we can explore.
Joel, I think that I'm going to stop the recording here. We're on the hour. I know some folks have to head off, and I know some other folks might have some questions they want to continue after the recording. Sure. Also, I think it's good to incentivize some of our folks who watch the recording to join us live, because this interaction is really important. Exactly. So our next talk is next week, Tuesday, February 23rd at the same time, 1700 UTC. It's from Alfonso de la Rocha, who's a research engineer at Protocol Labs in our Resilient Networks laboratory. He'll be talking about his project Beyond BitSwap, which you can read about at length on our blog at research.protocol.ai. If you're watching on YouTube, please join our mailing list in the footer of that same website. Remember to like and share this video, subscribe to our channel to be notified of future talks. If you want to suggest a topic or a speaker, you can read about how to do that in the description, or you can just email us at research@protocol.ai. Thanks everyone for joining us. We'll see you next time.